Okay, for each problem, find the average rate of change of the function over the given interval. So this is what we mean by that. So if you were here and you drew a straight line from here to here, what would that average rate of change? Notice up until this point right here, this slope is negative. But from here to here, this slope is positive. But there's an average. So remember back in 7th or 8th grade Algebra 1, you're going to use the slope formula to find the average rate of change. So the average rate of change and slope are interchangeable. Okay, so here is the slope formula right here. But look at this notation right here, and let me do this. Look at this notation right here. Notice that is not an xy value. That is square brackets telling you what the domain is. So on the graph, we're only going to be looking at where the graph is from 0 on the x-axis to 2. So these are your two x values. All right, let me bring that back to here. All right, those are your two x values. Well, to find slope, you need your y values. So you're going to take each one of those x values and you're going to plug them into the function. So when you plug 0 into this function, you're going to get 1. So one of the points is going to be 0, 1. Well, that makes sense right here. And then you're going to plug 2 into the function. Well, x squared is 2 squared is 4, minus 2 times 2 is 4. When you plug 2 in, you also get a height of 1. Well, if you look graphically, just look at that. What is the slope of that line? And in calculus class, you should all know that. But if not, if you weren't looking at a graph, if I didn't have a graph here and you were just needing to use a formula for that, we go ahead and plug in the two y values, so y1 and y2. So 1 subtract 1, well, there's our 0. And then x2 and x1. So 2 subtract 0 is 2. So in this case, the average rate of change is 0. Slope is 0, but slope is also referred to as average rate of change. Okay, so I'm going to cover up this stuff. I'll leave the slope formula right there. So now we have a different type of function, and we're looking at between 0 and here's 1, 1/2. Well, that is definitely not going to, that's a curve. If we were to blow that up, let me see. Yeah, that is a curve. So we can't typically just use to know exactly at each point what the graph is. But if we're talking about the average, then we're just talking about a straight line between those two things. So you're going to plug each of those x values into the function. So you're going to end up with 0 something and then 1/2 something, and plug those values into the slope formula. So when we plug 0 into this, well, 1 over 1 is 1. And when we plug 1/2 into this, well, 1/2 plus 1 is 3/2. So 1 over 3/2, we're just going to multiply top and bottom by 2/3. Those cancel. So then we have, when we plugged in 1/2, the y value is going to be 2/3. Now again, this is the x and y, this is the x and y2, this is the x and y1. So we plug that in down here. So y2 minus y1. Well, 2/3 subtract 1 is negative 1/3. There we go. And 1/2 subtract 0 is 1/2. Well, we don't want this complex fraction, so we're going to multiply top and bottom by 2. Those cancel. Negative 1/3 times 2 over 1 just gives us negative 2/3. And we can tell that that graph right there has a negative slope, so that seems about reasonable. And I think that might be, yeah, I'll start anew.